Have you ever wondered why, when one of those Christmas lights goes out, they all go out? Stay tuned, we'll find out why. Hi, and welcome back to the channel. If you're new here, I'm Robin DeMarco, the online physics teacher, and my passion is taking the mystery out of science and really helping you to supercharge your experience. I started off by asking about Christmas lights. We've all had that experience. We put the Christmas lights up around the tree, and one goes out and half the string goes out. And the question is, why? The answer to that question comes from looking at how the lights are connected. What we find is that the lights are connected in a series, in a string, and that's called a series circuit. Now, before I go into a full definition of it and a demonstration of it, let's just talk about other series you're aware of and how that can apply to what we're looking at here in electricity. When I talk about the World Series, what is that? Well, we know it's a baseball game, or a series of games really. And again, I use the word series. Well, it's the same two teams playing each other over and over and over and over until somebody gets the best of 7. Okay? Once the World Series starts, there's only one way for you to become the champion. You've got to win 4 games. So that's really the start of this. We can see this, a series is where we have one path we have to take to get to the end. Let's take a little trip over to the whiteboard and we'll give an idea on how this is going to be applied. We often talk in physics about something called a series circuit. So what do we mean by a series circuit? Well, the quick, easy definition is it's a circuit with only a single path. So to give an example of what this might be is, let's say we have a battery, and that battery is then connected to a resistor of some sort, to another resistor of some sort, and finally to one last one before it goes back to that battery. Now, this is an example of a series circuit, and what it's showing us here is that we have a single path. And in fact, if I take my pen, I can follow from the one point of the battery all the way around and never lift my pen. And that's one of the key tests you can do that quickly tells you if this is a series or parallel circuit. It's got one path, it's a series. The interesting thing with a series circuit is that the current that is flowing through the circuit, the total current, since there is no break in this line, it's going to be the same current that's going to go through the first resistor, and the same that's going through the second, and the same for the third. Okay, so we find that the currents are going to stay the same. Now, we saw before when we looked at Ohm's law that the voltage over each one of these, each resistor is going to have a specific voltage drop. So between the point we start here and the point we get back, we have a change in voltage. So looking at the whole picture, we're going to have a voltage drop here, a voltage drop here, and a voltage drop here. And what we're going to find is that the total voltage is going to be a result that's going to give us V1 plus V2 plus V3. It's the combination of all 3 of these pieces. And lastly, we quite often want to look at things like resistance. Now, the resistance in a circuit can go back to Ohm's law. Now, we said that Ohm's law was V equals I times R. Now, in this case, we want to find resistance. So we're going to do a little bit of math here. So to get the resistance, what we're going to look at is going to be the voltage divided by the current. So that tells us that in this case here, the total resistance is going to be equal to the total voltage over the total current. So what we're going to get here is we have V1 plus V2 plus V3. And on the bottom, we're going to have I1 equals I2, which equals I3. Now, what this is going to mean for us is that we actually have a common denominator for all this. What we're going to see then is that all these I's can be replaced then by IT. So what I'm going to have then is that V1 over IT. Oops, should have done that in red, sorry. IT, there we go. Plus V2 over IT plus V3 over IT. Now, since we've looked at this and we said that in each case that R equals V over I up here, I can substitute in here. So the R total is going to be, this would be R1 plus R2 plus R3. So this is what we expect to see when we do the example. Okay, what we've got here is a simple series circuit. It may not look simple simply because of all the wiring that's running on the table here, but let me just kind of walk you through it. Red line coming in is going to be attached to our battery. So I'll set that there. Goes through the red line, into the first light, through the yellow light, the yellow line, to the second light, green line, third light, and back over to our battery. So if we've got it all hooked up properly, when I touch the ends here, the lights will come on. Now you'll notice that they're very dim here. Okay, there we go. So when we hook this on, you can see that all three lights do come on. Now, one thing I forgot to mention earlier is if at any point in time we break the circuit, take one of these off, notice that all the lights go out. Reminds you of the Christmas lights, doesn't it? Another thing we're going to notice here is that the lights are very dim as compared to what we saw in the Ohm's Law series, where I just had the 9-volt battery hooked up and running into the a single light. All right. Now, according to what we saw earlier, remember, predicted that the voltage would be split. The same voltage coming out of the battery is going to be split across 3 different pieces. Now what I have here is an ammeter. This is actually a multimeter, not just an ammeter. And this one is currently set up to look at the current going through a circuit. What I'm going to do is I'm going to replace a wire. So I'm going to pull off the red wire here, and I'm going to connect it to the red, connect it to the red probe right here. Now the black probe coming out of the device, I'm going to connect with the green wire, and now this green wire is going to come back here and make our connection. And again, we see that lights are back on. And now we have a reading on our ammeter. Helps a little bit there. So now we have a reading on our ammeter. This is telling us that we have a voltage, or excuse me, a current of 0.003 amps running through. So we have 3 milliamps that are currently running through the circuit. What I'm going to do now is take another multimeter, and I'll put it over here so we can see this a little bit. We can't read it over there. I guess we'll just slide this one over. There we go. Now I can read that. And this one is set up to read the voltage. Now we know from our Ohm's law experiment, we know that these have approximately a 1200 ohm resistance. We can go through and figure out what the voltage drop should be, but we expect this to come out, because of all the pieces that'll be in the circuit, we expect this to be somewhere around a 2-volt drop across each light, a little over 2 volts. So what I'm going to do is I'm going to take the probes, and I'm going to touch across the light. So I'm going to touch here and here. Okay, and we're seeing right now that we've got, still have our roughly our 3 milliamp current, and we've got a voltage drop of about 1.8 volts across that first lamp. Let's repeat that on the second lamp now. Our second lamp is right here, and we see that it's up 1.86 volts as well. Going to our last lamp, we've got a 1.8 volt drop here as well. So what we're seeing is that the voltage drops, assuming all these resistance are exactly equal, the voltage drop should be exactly equal as well. Now we're not seeing exact numbers. Why? Well, different length of wire was used in each of the little pieces that are sticking off the bottoms. We have some of the soldering might not be as good, and so we may have more internal resistance built up. But that's basically it. So in conclusion, what we were able to show was that in a series circuit, the current is the same through each device that's in the circuit. We can find that the voltage drop is the total voltage drop will be the sum of all the voltage drops across each of the devices. And the total resistance in that circuit is going to be the sum of all the resistors that are in the circuit. I hope you enjoyed today's video, and I hope that you'll give me a thumbs up. Let me know you like this, and please think about subscribing so you'll know the next time I release a video.